Um, hello everyone. So, welcome once again to Trigonometry grade 10. So now, in today's lessons is sicala sort of trying to define the trigonometric ratios Z3 esesizicalile sine, cos, and tan for angles that are between 0 and 360 degrees. So far into esenzile ukuthi sicale only angles that are less than or equals to 90 degrees. La bese introduce khona ama trigonometric ratios nge right angled triangle. So now we are bringing all of that into the Cartesian plane where our angles will be between 0 and 360 degrees. So as an introduction, ngokuthi sifunde lawa notes from Isiavula, right? So now we'll be defining the trigonometric ratios in the Cartesian plane. So as an introduction, let us just read through this. So Lanabati, we have defined the trigonometric ratios using right-angled triangles. So now we can extend these definitions by any angle, noting that the definitions do not rely on the lengths of the sides of the triangle, but on the size of the angle only. So if we plot any point on the Cartesian plane and then draw a line from the origin to that point, we can work out the angle between the x-axis and the line, right? So we will first look at this for two specific points and then look at the more general cases. So la into bayisho bathi okay, let's introduce ama trigonometric ratios sisebenzisa ama right angled triangle, right, where we've defined that sine is equals to opposite over hypotenuse, cos theta is equals to adjacent over hypotenuse, and tan theta is equals to opposite over adjacent, right? Now we want to extend these definitions for any angle, right? Not only defining them in a right angled triangle. So okunye bakusho ukuthi these definitions of the trigonometric ratios, they don't depend on the length of the sides of the triangles, but they only depend on the angle, right? So meaning we can sort of define the trigonometric ratio if we have an angle, because they don't depend on the sides. Okay, so now if you have a Cartesian plane like we have in this case, and then you draw any point, right, any point, and then connect that point to the origin, you will have this line, right? Let us look at point P there. If you draw point P, okay, let me copy this to our writing board. Okay, so now we have this, we have a Cartesian plane, x and y axis. We have the origin there where both x and y are 0. Now if you draw any point in the Cartesian plane and then connect it to the origin, you'll have sort of like that line, and then when you have that line, you can measure the angle between that line and the positive x-axis, right? And then always when we are measuring angles, we measure the angle between the line and the positive x-axis. So if we have this line and then we we rotate this anti-clockwise, the angle that we measure will always be between that line and the positive x-axis, right? So now we have a point P, L number coordinates 2 and 3, so meaning x is 2 and y is 3, right? X is 2, y is 3, right? So if x is 2, it means lagu x-axis, this is our point, right? X, and then at the same time x is 2, at the same time y is 2, so we elevate to that point where y is 3, x is 2 and then y is 3, right? So, and then if you draw this dotted line, you'll notice it is perpendicular to the x-axis, giving us a right-angled triangle. Because we have initially defined our trigonometric ratios to right-angled triangle, we can continue the same way in this case, right? So this side of the triangle, we will call it y, and then this side of the triangle, we will call it x, ne? And then we will have our hypotenuse and call it r, right? So now when you are defining the trigonometric ratios, because we have said that these definitions of the trigonometric ratios, they don't necessarily depend on the sides, on the length of the sides, but they depend on the angle, right? So in this triangle, let us call that angle there theta, right? That angle, let's call it theta. So if you say sine theta, by our definitions, we know kumbulu sokatoa, by our definitions, we know that sine is opposite over hypotenuse. In this case, the opposite side is y. Theta is facing that side. That's the opposite side. And then our hypotenuse is that side opposite to the right angle triangle. In this case, the hypotenuse is r. So when you define sine theta in this scenario, you will see that sine theta is equals to y over r. Again, when you define cos theta, you'll see we know what cos is adjacent over hypotenuse. The adjacent side is this one next to the angle theta. In this case, that adjacent side, we call it x. So when you define cos theta, let me create a bit of space. So when you define cos theta, in this case cos theta, when you define cos theta, you'll see cos theta is adjacent over hypotenuse. In this case, the adjacent side is x, the hypotenuse is r. So that's r there, it's x over r. And then when you define tan theta, tan is opposite over adjacent. So tan theta will be equals to, the opposite side is this one, it's y. The adjacent side is this one, it's x. So when you define trigonometric ratios ku Cartesian plane, meaning when you define them ku x and y axis, this will always hold. So when you think about a Cartesian plane and the trigonometric ratios, think about this, right? Think about this. So sine theta is y over r. R will always be positive, ne? R will always have a positive because it's a length of that side OP. So if we call this O, it's the length of this OP. So R will always be positive, ne? But then as you rotate this line around the anti-clockwise, in an anti-clockwise direction. Let's say you rotate it to this point, right? When you rotate it to this point, r is still the same, right? R is still the same. So manje siku first quadrant, and then we take this line and rotate it to the second quadrant, right? So notice kuti ku first quadrant, like all the sides are positive. R is positive, y is positive because y is 3, x is positive because x is 2. Now when you come to the second quadrant, r is still positive, and then x is now negative, right? X is negative, right? And then y is still positive. So this means that the ratios, the trigonometric ratios, will sort of like 10. So the trigonometric ratios will sort of change when you rotate this line around the Cartesian plane, because as you rotate it, ukhumbule sithe we measure the angle between that line and the positive x-axis. So now when nasi go first quadrant, our angle is theta, is that one, ne? And then when we rotate this line, and then we take it to the second quadrant, now theta is that angle there, right? Theta is now that angle. So as we rotate, the signs of these trigonometric ratios will change, because as we rotate around the Cartesian plane, the values of x and y will change. So in this case, second quadrant, y is still the same, but then x is now negative, right? Yeah, I hope that makes sense. So okay, going back, let us rewind. Okay, now as well in mover, and then define ama values wala trigonometric ratios go first quadrant. So we have theta there, this is our angle theta, and then when you want to calculate the values of these trigonometric ratios, and it is the sine is y over r, right? And then we know what y is equals to 3, but then we don't know r. The way to calculate r, you will use the theorem of Pythagoras. So the theorem of Pythagoras says the hypotenuse squared is equals to the sum of the other sides squared, right? So the hypotenuse squared is equals to the sum of the other sides squared. So we know the value of x is 2 when you square 2, and then we know that y is 3, right? And then the hypotenuse will therefore be equals to the square root of 2 squared is 4, and then 3 squared is 9. And then now calculator this in your calculator. Now calculator this in your calculator with the square root of 4 plus 9. You'll see what that is, the square root of 13, right? So r is equals to 13. Now going back to your trigonometric ratios there, you want to calculate the value of sine theta. We say that is y over r. Y is 3, so that's 3, and then r is square root of 13, right? And then you want to calculate the value of cos theta. So that is x over r. So x is 2 and r is the square root of 13. Now we want to calculate the value of tan theta, that is y over x. Y is 3 and x is 2. Y is 3, x is 2. Okay, so yeah, that is how you calculate it. Now let us go back to our notes, not these ones. So finding an angle for specific points. So in the figure below, points P and Q have been plotted. A line from the origin, this is the origin, a line from the origin to each point is drawn, right? A line is drawn from the origin to these points. The dotted lines show we can construct a right-angled triangle for each point, right? The dotted line must always be down to the x-axis, as it is in this case. Now we can find the angles A and B. So A is this angle, A is that angle, and then B is that angle highlighted in gray, right? So points from the coordinates of P, we can see that x is equals to 2 and y is equals to 3. Therefore we know the length of the side opposite angle A is 3. So this side is 3, right? As we have it in here, this side is 3. Let me erase and okay. So but from the coordinates of P we can see that x is 2 and y is 3, x is 2 and y is 3. Therefore we can see that the length of the side opposite angle A is 3. Angle A is that one. The side opposite A is this. So the length of that side is 3, right? Let us see. The length of the side opposite A is 3. The side opposite A is that one. So the length of that side opposite A is 3. Right, and then and the length of the side adjacent this angle A is 2. So the length of the side adjacent A is 2. So this is the length of the side adjacent A. It is 2. So that one is 2, right? That one is 2. So using tan theta, tan of angle A, that is opposite over adjacent. This side is 3, that side is 2. So when you say tan A, you will have 3 over 2, right? And then now you can calculate A using this. Okay, let us go back to our board. So okay, so this is angle A, that is angle A. Now we can calculate, and that one is a right angle, it's 90 degrees. We can calculate angle A. We can calculate angle A because we know the side adjacent side to A and the opposite side to A. Using our trigonometric ratios, we can calculate angle A. So katoa. So if you say tan of angle A, that is equals to opposite over hypotenuse. Opposite over adjacent. The opposite side is 3 and the adjacent side is 2. Now we want the value of angle A. In your calculator, you'll press shift and tan, and then you will have that angle A is equals to 3/2. Angle A is equals to 56.3 degrees, right? 56.3 degrees. So that is the value of angle A, right? Go back to our notes. So now consider point Q. Point Q is that one. It's in the second quadrant. We can also use the theorem of Pythagoras to calculate the hypotenuse. Okay, let's say this side is the hypotenuse because it's opposite the right angled triangle. Right, so we can use the theorem of Pythagoras to calculate the hypotenuse of the triangle and then calculate the value of A using sine and cos. Okay, so just to demonstrate, I think you go and say loco and calculate the hypotenuse. Kumbule, so we can define this as the hypotenuse city r, ne? And then here this is y, that is x. So calculating the hypotenuse r, that will be the square root of, and then stoluguti r is the square root of 13. So now when you say sine A is opposite over hypotenuse. The opposite side is 3. The hypotenuse is the square root of 13. Now when you want to calculate the value of this angle using sine, uzoti shift sine in your calculator and have this. You should get the same answer as we did in there, right? So if you say shift sine and then with 3 over the square root of 13, you'll see what is still the value of angle A is 56.3 degrees. Again, when you use cos of angle A, cos is adjacent over hypotenuse. The adjacent side is 2. The hypotenuse is r, which is root of 13. Now if you want to calculate the value, oh sorry, that is 2. That's 2. Okay, you'll see what is still angle A is 56.3 degrees, right? Okay, let's go back to our notes. Consider point Q. Point Q is that one there, ne? And then we define angle B as an angle formed between OQ and the positive x-axis. Angle B is that one highlighted in gray, right? This is called the standard position of an angle. Angles are always measured from the positive x-axis in an anti-clockwise direction. The angles are measured between the positive x-axis and this line in the anti-clockwise directions. So they are measured like that, right? So let alpha be an angle formed between the line OQ and the negative x-axis. So now going back to our board, alpha, okay, I think Sulela and bring on our sketch again. So now looking at this, right, we are now looking at the second quadrant, ne? We are at this point Q. So angle B is that one in gray, ne? That is angle B. The one in gray, that's angle B. So now we can define another angle between this line OQ and the negative x-axis as alpha. So that is the angle I'm talking about there. Right, now to calculate alpha, we will have that alpha, if we have a straight line, an angle, the sum of the angles in a straight line is 180 degrees. Right, why? Because if you divide that line by a straight line drawn perpendicular, you will have 90 degrees there and you will have 90 degrees there. Now when you add 290 degrees, you'll have 180. So we can calculate a can be calculated alpha, alpha plus the angle beta, the angle b should be 180 degrees. Again, notice with the triangle, the length of this dotted line is 3, right? And then the length of that one is 2. But then for calculation purposes, because we are in the second quadrant, that one is -2. And then when we define our trigonometric ratios, say this is still the hypotenuse, that is still r. And then when you calculate tan, also, okay, let's go back to SOHCAHTOA. Say sine alpha is opposite over hypotenuse. The opposite side, our hypotenuse is equals to the square root of 13. That one is equals to the square root of 13. So sine alpha is the opposite side divided by the hypotenuse. Cos alpha is the adjacent side, so that is -2. -2 divided by the square root of 13, right? Tan alpha is the opposite side divided by the adjacent side. Notice with the second quadrant, now when we are defining these trigonometric ratios, only sine is positive, the other ones are negative. Now let us go back to our notes. So let alpha be that angle. So let alpha be an angle formed between the line OQ and the negative x-axis, such that when you add angle B and alpha, you will get 180 degrees. Right? From the coordinates of Q, we've known that we know the length of the side opposite alpha is 3 and the length of the adjacent side is 2. Using trigonometric ratios, now using trigonometric ratios, we can calculate the value of alpha, right? Tan is opposite over adjacent, and then tan is opposite over adjacent, right? Tan is opposite over adjacent. Therefore, alpha is calculated as to be 56.3 degrees. Now we can calculate the value of B from that equation there. You can calculate from that equation with him, because when you add B, angle B and alpha, you should get 180 degrees. You can now you have alpha, you can calculate B. Similarly, an alternative method is to calculate the hypotenuse and use the theorem of Pythagoras and calculate alpha. Okay, yeah, that is how it is. Okay, let us move on. Finding any angle. If we if we were to draw a circle centered on the origin and passing through the points P, then the length from the origin to point P is the radius. The circle is the radius of the circle, which we denote by R. We denote the angle formed between the line OP we denote the angle formed between the line OP and the x-axis as theta. Right. Now we can rewrite the trigonometric ratios in terms of x, y, and r. The general definitions of the trigonometric ratios are these ones. Okay, let us copy this circle to our board. Okay. So we now have a circle, it is centered around the origin. Now we draw from the origin is this one, where x and y intercept. The origin is that point, and then we draw a point lapha ku circumference a circle, and then connect it to the origin, so we get that line there, OP. This is O, we get that line OP, and then we call that line OP the radius, and then in our case we define it as R. It is the radius. Now we can define the trigonometric ratios because we can measure an angle between the line OP and the positive x-axis. Now notice ukuthi the length of this side of the triangle is x, and then the length of that one is y. Now we have an angle theta there, right? So because we have an angle and a right angled triangle, right, we can define the trigonometric ratios, right? So once we add trigonometric ratios, think about SOHCAHTOA. So this will be SOHCAHTOA will be key to all of our questions. Okay, so now if you say sine theta, we know that sine is opposite over hypotenuse. In this case, the hypotenuse is R, and then the opposite side will be y. So y, sine theta will be y over r. Opposite over hypotenuse, y over r. Cos theta is adjacent over hypotenuse. The adjacent side is x, the hypotenuse is still r. Right? Now, r. Now tan theta is adjacent, is opposite over adjacent. So that's y over x. Okay, so going back to our notes, this is how we have defined it. And then the reciprocals, okay, we also have reciprocals. Kumbule ukuthi the reciprocal of sine is cosec, right? Cosec theta is the reciprocal of sine, meaning cosec theta is 1 over sine theta. So this will be cosec theta. You will just invert or swap the denominator and the numerator. So now we are lapha sine. If you swap the denominator and the numerator, will see that cosec theta is equals to r over y, and then reciprocal yaga cos to sec. So sec theta will be equals to r over x, and then the reciprocal of tan is cot. So cot theta will be x over y. That's it. That is how we define trigonometric ratios ku Cartesian plane. Now the Cartesian plane is divided into 4 quadrants. The first quadrant, second quadrant, third quadrant, and the fourth. So the Cartesian plane is divided into 4 quadrants in an anti-clockwise direction, as shown in this diagram below. Notice that the radius is always positive, but the r is always positive, but the values of x and y change depending on the position of the point in the Cartesian plane. So as a result, the trigonometric ratios can be shown, the trigonometric ratios can be positive or negative. The letters C, A, S, and T indicate which of the ratios are positive in each of the quadrants. So in this quadrant, all the ratios are positive in the first quadrant, and then only sine is positive in the second quadrant, only tan is positive in the third quadrant, and only cos is positive in the fourth quadrant, right? So this diagram is known as the cast diagram. So here you will have all ratios positive. Here we will only have sine positive. Here you will only have tan positive, and here you will have cos positive. So this is the cast diagram, but the cast, so only the cast diagram. So first quadrant, all the ratios are positive. Second quadrant, sine is positive. Third quadrant, cos is positive. Sorry, tan is positive with third quadrant, and then fourth quadrant, cos is positive. Okay, so that is the cast diagram, right? We note the following using the general definitions of the ratios. In quadrant 1, both x and y values are positive, so all the ratios in this quadrant are positive. In quadrant 2, the y values are positive, therefore sine and cosec are positive in this quadrant, right? Recall that sine and cosec are defined in terms of y and r. Okay, that's just a side note. In quadrant 3, both x and y values are negative, so only tan and cot are positive in this quadrant. In quadrant 4, x is positive, but then y is negative, so there only cos and its reciprocal are positive, right? Now special angles in the Cartesian plane. So kumbula special angles would it's 0. Okay, special angles, special angles so 0 degrees, 30, 45, 90. Those are our special angles. 60 also. Sorry, before 90 we have 60. Okay, special angles 0 degrees, 30 degrees, 60, sorry, 45 before 60, 60 and 90. Special angles, those are special angles. So now kutiwa special angles in the Cartesian plane. When working in the Cartesian plane, we include 2 other special angles in right angled triangles. 0 degrees and 90 degrees. Notice that when theta is equals to 0 degrees, the length of the opposite side is equals to 0, and the length of the adjacent side is equals to the length of the hypotenuse. Therefore, sine sines okay, let me try to demonstrate this Cartesian plane. Okay, let me try to demonstrate this. So we want to calculate when theta is equals to 0. What does this mean? It means this angle is 0. How can it be 0? We can only have a 0 angle if we bring this point down to, so if you bring that point down to the positive x-axis, that right, that's when you'll have that angle 0. So that is r, ne? So this angle will be 0 if y is 0, ne? So when you say sine theta, so sine theta is 0. So if it is sine of 0, sine is y over r. So that will be 0 over r, which is just 0. Negative cos theta, theta is 0, cos is x over r, right? So notice kuti x x, in this case x will be what? Will be r also. So if I take this point to here, x will be r. So our coordinates will be like that, right? So this will be r over r, and then we'll have this as 1, right? And then negative tan theta is 0. That is y over x. So it's 0 over x. This will be 0. So yeah, that is how into bazama kuyichaza la kule first paragraph lana into bazama kuyichaza ngileyo in this paragraph. So when theta now is equals to 90 degrees, the length of the adjacent side is equals to 0, and the length of the opposite side is equals to the length of the hypotenuse. Therefore, okay, let me try to demonstrate this one also. Okay, so when theta is equals to 90 degrees, when theta is equals to 90 degrees, then we want to calculate the trigonometric ratios. So theta is that angle there, right? So if we want to make it to be 90 degrees, we can rotate this line anti-clockwise to be at that point, right? So at that point, if we take point P to this position, in this position x will be 0 and y will be equals to the hypotenuse, the radius. That is the radius, right? So that will be the situation. Now in this position, theta will be 90 degrees, ne? So because we've defined our trigonometric ratios like this, this one stays y over r. This one 30 is x over r. This one 30 is y over x. Right, so y is r, ne? R is still r. So sine theta, when theta is 90 degrees, sine theta will be 1. So sine of 90 degrees is 1. Cos theta, now x is 0, and cos theta, when theta is 90, cos will be 0. Cos theta will be 0. Now tan theta, when theta is 90, is undefined because you will have r over 0, and then dividing by 0 is undefined. So tan theta is undefined when theta is equals to 90 degrees. So yeah, into bazama ukuyichaza la gileyo. Okay, so special angles. Ukhumbule nalama triangle lawa angathi uwa memorize if you can, right? So yeah, I think ngizojama la and send these questions, this example as a challenge question, this one. So this will be our challenge question. Okay, so let me copy that challenge question. Oh, sorry. Let me copy the challenge question and post it here. Okay. Okay, so now this will be the challenge question, eh? Do this as a challenge question, and then on our next lesson we will discuss the solutions. So do this as a homework or whatever, and then in our next lesson we will discuss this. So pause the video and do this as an exercise, so stay understanding yakho. But the point P has those coordinates, is a point on a Cartesian plane with origin 0. Theta is the angle between OP and the positive x-axis. Without using a calculator, determine the values of the following. So as a guide, nabat nigela point P on a Cartesian plane. So draw a sketch on a Cartesian plane and then find the coordinates of this point P kuleo Cartesian plane, and then connect that point to the origin, and then draw from that point, draw a dotted line to the x-axis, and then you will have a right angled triangle. So once you have that right angled triangle, calculate the hypotenuse. When you have the hypotenuse, it will be easy to calculate these trigonometric ratios here. So yeah, that's a guide that I'm giving you. Try it. In our next lesson we will discuss the solutions. Okay, yeah, that is it for this video.